Swayam Prabha. Digital India. Educated India.
Welcome to the class. Till time what we have seen is that there is Rankine cycle, and that Rankine cycle is used for applications either to be as a prime mover or maybe for electricity generation. This is what we had seen. We had seen that there are four major components of Rankine cycle. First one was pump, second one was boiler or steam generator, third one was turbine, and last one was condenser. Now we had seen all the thermodynamic analysis part of the Rankine cycle. We had also seen how Rankine cycle can be clubbed with other cycle, what can be the medium of the Rankine cycle, or what are the properties of Rankine cycle, how to do computations and analysis of the Rankine cycle. This all part was done till this point. Now here onwards we are going to see the components of Rankine cycle, and majorly in this class or in this subject, as what we know, we are going to study steam generators, turbines and the condenser. So here we are going to start with steam generator in this class. So steam generator. So we know that this is a typical figure or photograph of a steam generator, where our basic motive was through the steam generator is we are having steam to be produced from the liquid water. So to the steam generator basically we will have liquid water which is at high pressure will be supplied, and that high pressure water will be heated in the steam generator such that we will get the steam at the same pressure of the water which is supplied. So then there can be different components of the steam generator, or there might be different arrangements of the steam generator. That is what the topic of discussion for this class. So types of steam generators based on application. So we mean that we are trying to use steam generator for different applications, as what we had seen from our earlier power classes. Based upon that we are trying to classify different steam generators. So first is called as utility steam generator. So utility steam generators are basically used for electricity generation in the power plant. So big power plants which are mainly motivated towards production of electricity, so those power plants steam generators are called as utility steam generators. Then these steam generators further get classified as two types. One is subcritical steam generator, another is supercritical steam generator, and obviously these two types are based upon the pressure of the steam which is supplied to the steam generator. So if we say that a utility steam generator is of subcritical type, then it would be handling steam of around pressures 130 to 180 bar. Further, subcriticals, after subcritical steam generators we have supercritical steam generator, and then those who deal with the steam which is of the pressure more than 240 bar. Further, supercritical steam generators are drumless type and then once through type, where they will go once and then they will get heated, water will go once and then it will get heated and get converted into steam. Then modern steam generators have steam flow rate as what in our Rankine cycle we were calling it as specific steam consumption. So for the turbine we were needing certain amount of steam flow rate, and so that steam flow rate is what we indicate here as steam flow rate or steam rate. So the steam rate is as high as 120 to 1300 kg per second when the electricity generated is around 125 to 1300 megawatt. Second type of the steam generator is industrial steam generator. These steam generators are practically used for the processes where steam is a high temperature source, and we have seen that those processes are the processes in the industries like sugar, jute, paper, or in the house heating kind of applications. So, the industrial generators are comparatively of lower size, and then these generators are mostly in Indian context we see them as coal fired, and or they may be using the waste heat from other heat processes or other processes of the industry. There might be some waste heat, those waste heat, that waste heat these generators might use to convert the liquid water into steam. These steam generator work in the range of pressure 5 to 105 bar, and then they work with steam flow rate of around 125 kg per second. So, these are industrial steam generators. Industrial steam generators sometimes need not produce steam which is superheated or saturated. It might produce steam which is wet, as they are mostly used for industrial heating applications. Then we have marine steam generators. These marine steam generators are mainly used in ships or ocean liners, where the steam turbines drive basically the ship. Then they are most generally they are oil fired, and then they may operate as superheated steam when they are operated with the pressures of 60 to 65 bar. So, we have seen based on application we have utility steam generator which is big in size, then we have industrial steam generator where steam is basically used as heat source, and we have marine steam generator where marine applications would have some boilers. Then we have types of steam generator based on flow of gas and water. We know that, as we had seen, that there are flue gases, or there is combustion of the fuel, and that combustion of the fuel those will lead to the combustion products which are hot, and those hot combustion products practically would heat the water. So, this type is based upon the path of water and path of the gas, flue gases. So, in this type we have first as fire tube boiler. So, here products of combustion or flue gases flow through the tubes surrounded by water body. So, this is an example where we can see that there is coal, and this coal is getting burnt, and then this fire will pass through the tubes. The advantage of such boilers are they are of low cost initially, and then they are reliable in operation. We can get basically large storage of water, so it is quick in response to the load, and then for its maintenance we need less skilled labor. So, these are some advantages of fire tube boiler. But these fire tube boilers can be externally fired or can be internally fired. So, this application is, this type of boiler is called as externally fired boiler, where example is locomotive boiler or Lancashire boiler. So, the fire is, or the furnace is outside the boiler shell. Such boilers are called as externally fired boilers. So, here the process of operation of this boiler would be, here we will first have coal. That coal will get air from around, and then this air and coal will burn, and then this burning would lead to the flue gases or combustion products. Those combustion products will go from the tubes which are placed in the water. So, as it is said to be the fire tube boiler, the flue gases which are hot, they will pass through the tubes, and in this process the heat exchange will happen between the hot gas from the tube to the water, and then they will pass to the chimney. But in case if we have higher heating of the water more than expected, then there is an element which is called as fusible plug, a component of the boiler. This fusible plug will melt, and then this melting of the fusible plug will drop the water on the coal, and then operation of boiler will stop. So, this fusible plug is a control unit for the temperature of the water supplied or steam supplied. Then there is pressure safety valve. Here this is a spring based mechanical safety valve where spring pressure will be adjusted such that the force of the pressure of the steam and the spring will get balanced and the valve would remain closed. If the pressure of the steam is higher than the expected value, then it will cross the pressure of the spring force, and then by this means this will open the lid of the valve, and then steam would flow out till the pressure gets equilibrated, and then we get balance of pressure. So, pressure safety valve is useful for control of pressure, fusible plug is useful for the control of temperature. Then there are other operational units or other parts, something like pressure gauge we will have water level indicator. So, all these things are integral part of the boiler. Then internally fired fire tube boiler will have the shell and furnace integrated with each other. Example is Scotch marine boiler or package boiler. Example as what we can see here, that the oil will first get filtered when it is used as a fuel for this burning, and then filtered oil will be coming into the nozzle, and then we will parallelly get the air into the nozzle. Then we will have fuel air mixture coming in a corrugated passage where they will get burnt, and this burnt product will pass through the tubes in a zigzag manner, and then in this phase they will heat the water which is surrounded by those tubes, and we can get the steam of our required pressure and temperature. So, this is the concept of internally fired fire tube boiler. But in all, disadvantages of fire tube boiler that we practically would need very large amount of water storage, and since we need large amount of water storage at very high pressure, so we basically would need large amount of time for initially getting the water at the desired temperature. So, further if we want the pressure to be increased, then accordingly our material cost would also increase. So, high pressure of the boiler is basically making it as a pressure vessel, and this pressure vessel should need to have very high thickness of the walls, since it has to sustain higher pressure of the steam. So, total boiler walls, complete boiler walls need to be of large thicknesses. So, it increases the cost of the boiler making. So, that is what the disadvantage of fire tube boiler. Then the second type based upon the flow of gas and water is called as water tube boiler, and in water tube boiler we will have water passing in tubes from the exhaust or combustion products of the reaction. So, this is an example where we have this boiler, where we will see that this is a drum of the boiler, and this drum is passing the water like this, and this water flows in this direction, and it gives us steam of our required pressure and temperature. This circulation of steam in this path will heat the steam using the gases which are getting flown around it. But here we need not have complete body or complete furnace to be at high pressure, since only water walls or the tube walls in which water is flowing is going to experience high pressure, since water is only at high pressure along with the drum. So, here the complete container or complete unit need not be at high pressure. So, this is the advantage of water tube boiler. So, it is compact in size and it can operate at high pressure and high steam capacities. So, the operating pressures and operating steam flow rates for this boiler are high. As what we can see, the operation of this unit is like this, where water which is saturated or hot water will come down from this path and it is called as downcomer, and this is one header which is called as downcomer from which water will come down. We can see that there are straight tubes which are inclined to assist the natural convection, since water is having high density. So, that will come down due to gravity in this path, and once it is getting heated, it is decreasing its density. So, it is going up in this direction due to buoyancy force, and then it will get collected into the drum to the header which is called as riser, and then again such circulation loop will continue. So, we have two headers as downcomer and riser, and then we have drum. Further, in the path of the gas we will have the water tubes plus the superheater as well. Here we can have different arrangements of the drum. This arrangement what we are seeing on the screen is called as longitudinal drum, where tube and drum they are at least in a plane which are either parallel or which are on the same plane. So, this has one little disadvantage, that it cannot accommodate many number of tubes. So, the pressure which it can sustain or which it can be used for as per its capacity is around 12 to 23 bar, and its steam capacity is in the range 0.63 to 10 kg per second. This is for longitudinal drum boiler. But we have cross drum boiler, where the plane of the drum is perpendicular to the plane of the tubes, such that it can accommodate many number of tubes in it, and such that it can lead to very high pressure inside the drum of the steam 12 to 100 bar, and it can produce steam at a very large rate from 0.63 to 63 kg per second. So, this is how we have the construction or different arrangements of water tube boiler. Further, although arrangement is different, but we still would have downcomer, riser, superheater and or other arrangements or other attachments to the boiler. Straight or cross drum boilers would implement baffles. We can see here in last figure, basically we can see these black strips, they are baffles. They will guide the path of the flue gas such that it can get maximum utilized for its heat, and most of it should be given to the water, and it should increase the temperature of water or steam such that necessary enthalpy at a given pressure and temperature should be delivered by the boiler. So, there is always provision of baffles to guide the exhaust gas or flue gas. Disadvantage of straight boiler, that it can accommodate less number of tubes. So, further what we can see that both whether cross drum or the straight drum boilers, both of them are having tubes which are straight. So, these are straight tube boilers. So, the straight tube boilers face a problem of having lower accessibility. So, we will have lower inspection ability, so poor inspection, and further circulation becomes sluggish since the tubes are straight over here. So, in view of this, we have a new concept which is called as bent tube boilers, and these boilers are basically having greater accessibility, there is better inspection possible, and then they can operate at higher steam rate. Example is Stirling boiler. So, the graph or schematic of such a boiler would look like this, where the tubes connecting to the different drums. This is a 3 drum Stirling boiler where we are having 1, 2 and 3 drums, and there is one more drum This drum is called as mud drum, since it collects unnecessary precipitates from the water, and then the tubes which are connecting to different drums, they are not straight and they are bent tubes. So here we will have burner, and this burner would pass the flue gases, and those flue gases will pass over the front, second and the rear tubes, and then it will go to the air preheater. Okay. Parallelly we will get the water which is from the feed water or from the pump to the rearmost drum, and from the rearmost drum these tubes which are downcomers, it will come down toward the mud drum and it will get heated. In this process it will get risen from the first and second blank of tubes, and then it will get into the center and the first drum. These drums are connected with each other so as to have their level similarity, and then they will give the steam of required pressure and temperature to the superheater or to the turbine first. However, intermediate to these evaporator tubes we have superheater tube also placed. In general, at gross, the arrangement of different tubes into the boiler or into the steam generator is like this, where we will have the water, the flue gas which is coming from the top, and then that will heat the superheater, and then it will heat the reheater, and it will heat the economizer at the end, and this is the wall of the boiler. And then in the wall of boiler we have the riser tubes, and these riser tubes will rise the water. This is downcomer. So this is the drum which we are having it outside the boiler shell. This is one of the schematics of the boiler or steam generator. Preferably such an arrangement is possible to have more efficient heat transfer, where we will have drum outside the furnace or outside the heat transfer zone, where flue gases are coming, they are heating superheater, they are heating the water which is supplied from the feed water heater. So feed water heater which is at high pressure will supply water over here, and then this section is economizer. From the economizer water will go to the drum, from the drum water will come down into the downcomer, and then it will get risen in the evaporator tubes. So these tubes are basically attached to the steam generator walls, and then once they are risen, then it will again go to the drum, and after the drum it will go to the superheater, and from the superheater it will go to the steam turbine. Intermediate to this we will have reheater, so we can get steam from the high pressure exhaust, and then this steam from the high pressure exhaust will get heated in the reheater and will be supplied to the low pressure turbine. So this is a schematic of flow of gas in the steam generator or flow of water or steam in the steam generator. Having said this, what are the requirements of a boiler? Basically, as I said, boiler is a high pressure unit or it is a high pressure vessel. So it's, since being a high pressure unit, we have to first think about its safety. So its operation should be safe. Further, for the maintenance it has to be accessible, all the parts should be accessible and we should maintain and repair them. Capacity of the boiler is also important, since boiler is supposed to produce steam at the desired capacity or desired steam rate and should supply to the turbine. Further, in discussions in previous classes we had also seen that there is an efficiency called as source efficiency, where we are burning coal or oil, where they will have certain calorific value. So we want to have efficient heat transfer from the flue gases to the water, or maybe from heat source to the water or the working medium. So that efficiency has to be improved such that overall efficiency of the plant will be higher, so that economy will be better. Construction of the boiler should be simple such that it involves lower cost, its initial cost should be low, and then boiler should have no joints and which should be exposed to the flames. Boiler should be capable to quickly start and loading. So these are some requirements from the boiler. Then what are the components of the boiler? As we had seen, drum was one of the components, but within the drum we have many attachments, and some attachments which are integral part of any boiler, they are called as mountings, and then some attachments which are extra, those are called as accessories. So among those we can see that there is a pressure gauge which has to be there to monitor the pressure. There has to be water level indicator to monitor the level of the water, and if water level drops, then it would change the temperature inside the steam generator. So water level indicator has to be there. It is important also for loading aspect. Further, safety valve to maintain the designed pressure in the of the water. We should have fusible plug to avoid overheating. We should have blow off cock to remove the sediments which are basically present during the operation, and then we have steam stop valve which regulates outflow of the steam. We have feed check valve which is a one-way valve for feeding the high pressure water into the steam generator. So these are some components of boiler. So having seen this, we end the topic of discussion, initial part of the steam generator. We will continue the next part in the next class. Thank you.